This lecture is going to be on ray diagrams, seeing objects that reflect light. What we're going to have to make sense of by the end of this lecture is that we're going to make sure we start we're going to use the language appropriate to make sense as to what is happening with light or photons that are interacting with, say, a mirror. We'll talk about how is it and why is it that we see ourselves in a mirror as a virtual image, as our reflection. So in reflection, the angle between the incident ray, we're going to be using this term incident ray, and the normal line, which is this line here, is equal to the angle between the reflected ray and the normal. In other words, this angle here is going to equal this angle here. So here's a ray diagram, and this is what we're going to be learning here today. Incident ray, that's my incoming ray, and reflected ray, that's the photon with the light that's bouncing off. We're going to be looking at this angle here of 30 degrees. It's 30 degrees measured from the normal line. That the incident ray is going to be equal to that as the reflected ray. So my angles are going to be equal to one another. So the law of reflection, and this is what we're learning. The angle of incidence, the angle between the incident ray and the normal line, that's this angle right here, this interior angle. Notice, it's always measured relative to the normal line. And we have an angle of reflection. The angle between the reflected ray, right here is my reflected ray, and the normal line here. That my angle of incidence must equal the angle of reflection. Remember, it is very important we refer to what this normal line is. So the law of reflection says that the angle of incidence equals the angle of reflection. And this law applies to any surface with specular reflection. So some key terms here. Rays. Rays, we're going to be referring to the incident and the reflected rays. That's the photon or the light that we're observing or paying attention to in our drawing. The normal line. This is perpendicular to the surface, and we'll draw it as a series of dashed lines. Angles, the angle of incidence and the angle of reflection. Both are measured from the normal, very important. And lastly, the surface that is reflecting the light or the photons. We're calling this mirror here as the surface, and we're calling this specular reflection. So, ray diagrams. The ray diagram we're going to be drawing, we need to make sure we can label these appropriately. The incoming ray is going to be the incident ray. And the outgoing ray is what we're going to say is the reflected ray. This ray is reflected off of this mirror or this specular surface. The normal line, dotted line, is always perpendicular to the surface. It has to be perpendicular. And therefore, the angles that we're looking at are going to be measured from the normal line. So the incident ray, based on the law of reflection, the angle of incidence must equal the angle of reflection. This is very specifically what the law of reflection says. So when we talk specular reflection, a ray of light that strikes a shiny surface, like a mirror, creates a single reflected ray. Each ray of light bounces off in a single direction. And this is why you can see yourself in a mirror. You only see yourself kind of in reverse. For reflection in a plane mirror, object size equals the image size, and the object distance equals the image distance. So if you are, say, 4 feet behind this or away from the mirror, you will see your virtual image or your twin in this picture 4 feet at exactly the same profile, same features and scenario that you are in front of the mirror. You'll just happen to see behind. You'll see yourself behind. And here's what's happening. Light that's bouncing off of you is reflecting diffusely, but light that is reflecting off the mirror is reflecting in the specular reflection manner. So we can actually apply both of these to one scenario. Now, here's an example of a video I found on the website. Here's my explanation. I think you can make sense of both of them. I'm going to play a little bit of it for you here. So I'm going to talk you through how and why we see ourselves on the other side as a virtual image. And I want to make sure you realize that a virtual image is what you see when you look into a mirror and you see yourself. And we'll talk about how and why. We're going to apply some laws of reflection to make sense as to how and why you see yourself over here. And so therefore I can draw my picture here as this person. And the important part here is that you realize that the law of reflection tells everything that we need to know about. So here goes. So why is this person here, the person who's actually looking in, why is it that they're able to see their virtual image? And it really comes down to the law of reflection. If I look here, let's talk about feet first. why does this person see this foot exactly as it is over here and this foot exactly as over here? Well, if we think of light that is striking the person, light is going to be diffusively reflecting off of this person, and it's going to be specularly reflecting off of the mirror. That this foot that is reflecting the light, right, it's going to reflect light into the mirror, and that mirror is going to make its way to your eyes. Well, if I extend this line here, they're going to be able to view the foot being in the proper place as if they were standing behind the mirror. But they're not standing behind the mirror. They just see the image because the light that reaches their eyes is going to view it as being here. Where we see the image, the virtual image behind the mirror. Remember, the virtual image. This individual behind the mirror that you see is not reflecting light. It's a virtual image. And as a result of this, we can take a look at the hand. So we can just say hand point, I'll call it X. Call this here X, that this hand is going to be reflecting light as well, but notice at a different angle. So therefore, the difference of the angle is going to show us where the hand is going to be perceived as the light, the incident rays are reflecting or hitting the mirror and reflecting to our eyes. So what happens here is you get a virtual image. You essentially get yourself as a reflection in the mirror as a result of not only the law of reflection, but because we're able to observe both specular reflection here along with diffuse reflection. So light that's bouncing off of you is going to strike the mirror and make its way to your eye, and you're simply going to perceive the reflection angles of the light as being able to perceive what object is taking place or what we make sense of those light, those photons, and you're going to view yourself behind the mirror. Once again, when you look directly into the mirror, you see light that reflects off of you, hits the mirror, it specularly reflects back, and you see yourself in your head at the same level, so your eye level. And really, if we were to look at any of these angles here, I can draw this here, and I can label my normal line. I'll do it in a different color so that it kind of stands out. That we know that the law of reflection says my incident angle here is going to equal my reflected angle over here, and that applies to all of these angles. Here it's going to be a little bit greater because it's coming from a greater angle, a total angle, and this angle here, so reflected here, makes its way to the eye. This is just going to be a smaller angle, where here it's going to be no angle because you're seeing it straight over. So the mirror is we're trying to make sense as to why this person sees themselves in the mirror, and hopefully that helps make sense.